So hello guys, in this video we are talking about interview questions on REST API, means iceberg ingestion using PySpark. So first concept is what is REST API and how do you call in PySpark. So REST API is a web service that allows HTTP standard. You interact with using methods like get, post, put, delete. Each endpoint returns structured data using JSON, usually in JSON. In PySpark, the Spark driver call the API using Python request library, not on worker, because REST calls need coordination, state, and token management, which does not fit the distributed workload worker node or model. Syntax is input REST API, then header is equal to in dictionary, authenticator is me and barrel token, comma, next is accept, and value is star slash star, means application star just. Then response is equal to request dot get in bracket URL, comma, headers is equal to headers. Then if response dot status code is double equal to 200, then data is equal to response dot JSON. Otherwise we will get the error called API failed with status, and we will get the error. What is the error? Then what is the difference between get and post request, and when do you see use it? Get method purpose is like read and fetch data. It has no body. Post purpose is send data or trigger actions. It has body, usually in JSON body. Get was used to fetch metadata like instance or and body list. No study list. No body needed, just URL parameters. Post was used to fetch protocol deviation records because filters like status approved had to be sent in the request body. Header also differ. Post request need content type, means application comma JSON, and get request does not. Next question: how do you handle authentication with the REST API? REST API use OAuth to password grant, means in that username plus password plus client credential, means username, client secret, and client secret and client ID. The flow: the first is post to the token endpoint with credential to get access token, and access token valid for 30 to 60 minutes. Attach it every subsequent request as authentication colon bearer token. Third is step is on 401, means unauthorized response, wait and refresh the token, then retry. Credentials were not hard coded, they were fetched securely from the credential vault, means NABU, at a runtime using service token, so nothing sensitive live in the code base. Next question: how do you handle token expiry during long running job APIs? So access token had a short available short time, example 30 to 60 minutes. For a job fetch hundreds of studies, mid run expiry is common. Approach is like first on 401 response, do not immediately fail. Re-enter a retry loop. Sleep for n seconds, usually 30 seconds, to allow token service to issue new token. Next, call get token method and compare the new token with previous one. Next, only retry API call if the token actually change. If it is same, keep waiting. After max retry attempts, raise customer token expired exception to cleanly propagate the failure. A customer exception class was used instead of generic exception. So a caller could distribute token failure for other error and handle them specifically in logging and reporting. What is pagination and how do you implement it? Most APIs don't return all records in one response. They split data across pages. Each page has fixed size, usually 15 records. each page having 50 records. So you must loop through pages until you have fetched everything. Implementation like variable page is equal to 1, all page is empty list. While we have to use while loop, in that take URL, URL is equal to base URL percentage page is equal to page 1 2 3 4, and page per page is equal to 15. Then get a response using get method, and store that response to data using response.json. Then record is equal to data dot get in bracket data comma dot get records. The exit condition was empty record list or explicit no data found message in pagination data metadata whichever come first. What is API rate limit and how do you handle it? A rate limit is when API restrict how many requests you can make in a time window. Example, 100 requests per minute. Exceeding it running 429 too many request error. Handling add configuration API rest delay using 3 to 5 seconds using time.sleep function between each study API call. Then next question is, in real world tip, like some API retry after in to 429 response header. You can use that value as sleep duration instead of fixed delay. Next question is PySpark. Why did you run API call on Spark driver, not on workers? REST API call require stateful token management, means refresh logic, retry loops. Sequential pagination means page n depends on result of page n minus 1. Next, single authenticated session per API. Spark worker are stateless, distributed, and does not share memory. If you push API call to worker, each task would need its own token. You had have no coordination between pages, and failure would be hard to recover. The correct pattern: driver fetch all data, collect it into Python list, create a Spark data frame for distributed processing, and means transformation, deduplication, writing. Next question: how did you convert API JSON response into Spark data frame? API response were collected as a Python list of JSON page. Each page had nested structure like in dictionary. API farm is colon study 1 2 3 4 comma date, again dictionary record colon list of the records. So steps are: pre-process nested field, convert dictionary or list field to JSON string using JSON.dump so they fit the flat schema. Then load pre-defined schema from .schema file, struct type from JSON. Create data frame, spark.create data frame in bracket list response comma schema is equal to struct schema. Explode record array using explode in bracket data dot records to get one row per record. Using predefined schema instead of schema interference, ensure consistency across run and avoid silent type mismatch. What is explode and when did you use it? Explode transform array column into multiple rows, one row per array element. In the pipeline, each API page response contain array of records. After creating data frame, you had one row per page with a nested array. Explore, fatten it. You have to import explore from the spark.sql function. Then df explore is equal to df.select in bracket API frame comma explore in bracket data comma data.records alias records. Before explore 10 records 10 rows per page, each with 15 element array. After explore 400 rows per rows ready for transformation and loading. Use explore outer if the array can be null or empty and you want to preserve those rows. How do you detect incremental records? Use PySpark subtract function, a set of different operations. Like subtract compress entire row or columns are dropped before comparison so that a system generate timestamp does not cause every row to appear as new. Like first we have to subtract like fresh data frame dot subtract in bracket existing data frame. So fresh existing data frame minus fresh data frame minus existing data frame. Only new records and updated records will be the result. Limitation of subtract: treat any record different as a new row. It does not tell you which column change. How do you detect deleted records? Records that existing in the target table but were no longer written by API are considered deleted. Detection: use left anti join means left table having the records but that records is not present in the right table. So only left, suppose left have 1 2 3 but right have 1 3 only, but two records are not present in the right table. So 2 is the output. What is composite key and why did you need one? So composite key is a unique identifier record using multiple columns combined into one string. We have to use df dot with column in bracket df composite key comma concat underscore ws in bracket in double quote pipeline symbol comma id comma study comma site id. So id pipeline study pipeline site id. Left anti join for delete detection. Merge condition into iceberg offset. What is the staging table pattern and why we are using? Instead of writing directly into the raw or target iceberg table, incremental data goes to the staging first. So reasons like the merge needed for staging as a clean complete bash. If anything fail before merge, raw will be the same or untouchable. So let's talk about Apache Iceberg. What is Apache Iceberg and why we chosen over the regular Parquet or Hive table? Apache Iceberg is an open table format for large analytical dataset. It sits on top of file format like Parquet and Hive. Like we acidic transition in a Hive or Parquet, no. In Iceberg, yes. Offset or merge, no. In Hive, yes. In Iceberg. Time travel we can do in Iceberg. Hive, not. We are not. So concurrent read or write we save in Iceberg and save in Hive. Partition evolution rewrite table in Hive or Parquet but in place Iceberg. What is merge statement and how do you use it? Merge handle upsert and update in the single atomic SQL statement. Syntax is merge into target table name as target using in bracket select star from stage as source and on condition target.id is equal to target source.id. When match and source dot delete is equal to y, then update set db is delete is equal to y and ts is equal to current timestamp. When match, then update set star. When not match, then insert star. What is iceberg table maintenance and why it is needed? Every insert and merge in iceberg create new snapshot of the table and generate new parquet file. Without maintenance over time, old snapshot metadata accumulate, means slow planning, perhaps file means storage, wasted storage, and slow query scan. So maintain operation each like old snapshot, expire old snapshot, then remove perhaps files and compact small file into the larger. Let's talk about design pattern and architecture. How do you ensure the job does not run twice simultaneously? Like we are using at the start run function. Job check the job audit table to see if previous job is still running in process. That for that we created is last job running function to check the previous job is running or not. The common without that, if we run two pipelines without that, the both truncate and insert to the stage simultaneously, both execute merge, create duplicates, produce incorrect audit count. Next question: how do you track job success, failure, or monitoring? The job uses a job audit table pattern. On start, insert into job audit in bracket job ID. That function record the job started. Then on success, we created update job status with success. That we have to use job ID, incremental count, and total count. That record count and mark success. On failure, we created update job status with error. In that we ID and error message. Record the exception message. This gives you teams to clear picture without having to read a raw Spark log. Next question: how do you handle partial failure? Continuous after failure means one bad study does not stop the entire job. Failed study are collected with their result. No silently drop. At the end, summary is logged. 15 studies attempted, 48 successes, 2 failed. The job still return data for 48 successful studies. Partially success is better than total failure. Scenario 1. Let's talk about scenario questions. First question: the API returned 200 but data is empty. So for some studies, how do you handle this? So empty study means empty array.